First of all, thank you to the organizers. I think it takes a lot of time to organize the user group. We do this, they do this actually by putting their time. They don't get paid for running the user groups, far from that. Look, today we're going to look at the data lakehouse architecture. I'm here to tell you that not many things have changed during the past 40 years from the original 40, 50 years, if you take into account the traditional one-tier data warehouse architecture. I've been in the data analytics space for over 10 years, and I've seen, one-tier data warehouses, two-tier data warehouses. Now we have the data lakehouse architecture. At the end of the day, the outcome, what you're trying to achieve is the same, right? So you're trying to consolidate the information from multiple source systems into a single repository and enable the business users to make business decisions through analytics. So that's the main goal, right? That's the main goal of the data warehouse. That's the main goal of business intelligence. And yeah, that's the main goal of any, IT employee, right? We're here to support our business, and we're the bridge between what they want to achieve and making that vision possible in the data analytics space. I've been in the some data architect and data consultant. I have my own company here in Brisbane, Australia, original from Argentina, but I've been living in Brisbane, Australia for already 6 or 7 years, enjoying the experience over here. Microsoft MVP for data platform and have certifications and so on. If you want to connect with me, the best method is to either send me an email or connect with me in LinkedIn. So let's look at today essentially agenda, right? So what look, this shouldn't be here. So this should be here. So what we want to look at essentially today is what the data lakehouse is from a framework design point of view, and then how it applies to Microsoft Fabric specifically. Okay, you can take the learnings from today, and they are going to be still valid for other technology providers like Databricks or Synapse Analytics Gen 2. So if you have any questions, just put them in the chat or just open the microphone and shoot. Okay. Let's start from the basics, right? So when I started to learn about data warehouses 12 years ago, so the definition that came across was the one from Bill Inman, right? Who is the father of the data warehouse. He was the first person who came up with the definition of a data warehouse. Look, two things. So the first one is you have to understand the data warehouse is a collection of data in support of management decisions. And I do recommend as a data practitioner, one of your as your colleague, to think of the bigger picture as well. You're not just building pipeline, building reports, or building or writing SQL queries or Python scripts. Okay, so you are supporting your business on making better business decisions. And the second bit is to focus on these characteristics. So if you're looking for a data warehouse, so it has to be subject-oriented, integrated, non-volatile, and time-variant. So let's go and quickly review those 4 characteristics and what Bill Inman meant when they came with this description. So the first one is the subject-oriented, right? So you want the information to be organized in specific entities. Some of you relate to this in the sense of the Kimball methodology. So when you think of dimensions and facts, right? And good examples for that could be you want to organize the information of customers, you want to organize the information of products, vendors, transactions, and so on, dimensions and facts. So what happens is that when you look at the customer information, in some scenarios, the information might be coming from different source systems, right? So you might have information related to the usage in the operational side, you might have the demographic information in the CRM, in the customer relationship management system, and you might have as well customers spread across multiple that you service spread across multiple systems, right? So the idea is to basically bring that information from all those systems and put it in the same place. The second one is that it has to be integrated. This is basically means what I just mentioned. So when you organize that information, you want to make sure that you apply best practices, and they're organized following a specific pattern. So you create think of tables, columns, and data types, things of data models from the starting point, from a conceptual to a logical to then the realization of that physical data model. And of course, bringing that information might be represented on the information might be in a relational database. It might be sitting in a software as a service vendor, and you might have to bring like a JSON information. You might have all those different types of information. You want to put it in the same place. Non-volatile essentially means that you try to keep track of the changes of the information, right? And for this one, I'll give an example, right? So if you have the order A in your operational system and you want to move that to the data warehouse, so you have order A in the data warehouse, the same will happen with order B and with order C. If you, for some reason, delete one of the orders in the operational system, you want to keep that information still in the data warehouse. You might put some metadata to that record, so you put that it has been deleted, what time it has been deleted, and so on. But you want to keep track of all that information. Time variant especially means that it has to be accurate at a specific point in time. So imagine customer A, so that lives in Sydney, and we create that in the data warehouse. So that customer lives in Sydney, but then what happens is that that customer moved to Brisbane. Again, in your ERP system or in your CRM, you might just update the field, so you don't keep track of the previous city and demographic information for that customer. But in the data warehouse, you create a new field. This is what we call essentially slowly changing dimensions. What we want to do with it is to make sure that we're able to understand customer behavior. So it's not that you have to do it, but these are capabilities that they have to be offered in a data warehouse architecture, essentially, to be considered a data warehouse. And historical data, as I mentioned before, you want to make sure that, and we've seen this many times. So when, for some reason, businesses like to change providers, right? And we'll see, because they are trying to follow like a market trend, or they are trying to find a competitive advantage of a specific vendor. But it's going to happen that your company is going to try to move their CRM system from one vendor to another one. It's going to happen with the ERP systems. It's going to happen with many of those systems. So they're going to be migrated to new versions, to new vendors. But your data warehouse has to be able to keep the information independently of the vendor and the application that you're using. So it has to enable you to do that. So that means that if, for example, you are using QuickBooks and then you move to Dynamics, so the data warehouse will still have the information structured and ready to help business to make those decisions. That's the main idea. Yeah, you have to do a lot of work on integrating the new system into the existing data structure, and you might have to change a few things. You might have new data points and entities that you have to factor in, but the data warehouse has to enable you to do that. And finally, you have to be able to offer summary and detailed data in your data warehouse. Essentially, this means that you might have the most granular level of information, right? And that will mean that you could have billions of rows. But essentially, the C-suite or the managers or team leaders or people who are using our data warehouse, it's unlikely that they will make a business decision based on only one record. So you have to be able to aggregate that data so they can look at the trends, they can look at the behavior of the customers, they can perform market analysis on their products, on their sales, marketing campaigns, right? You have to aggregate that data so they can make those decisions. So when you look at specific examples, and we know that many businesses, they are still running in an Excel spreadsheet. And I don't see anything wrong with that, because before having computers, there were still multi-billion-dollar companies, right? So businesses can still run. IT is there. IT and data analytics is a capability that is there to improve the efficiency on how they run the business. That's the whole idea. So can you run a business by using Excel spreadsheets? Clearly, you can run it, but you run into limitations when trying to enable the data analytics capabilities. By looking at Excel and looking at the characteristics that we just saw before, so essentially in an Excel spreadsheet, you could have organized the different entities. Yeah, we could have either different workbooks, one workbook per entity or subject, or we could have one workbook and one tab per subject. But then it becomes really difficult to integrate information from multiple systems, right? So can I easily import non-structured data into Excel? It'll become quite challenging. Excel is not built for that. Can I actually have something, so if it has been deleted from the source system, can I still keep the record in the Excel spreadsheet? Yeah, kind of you can, but it's really difficult to manage. So I would say that no. Can I have a slowly change dimensions in Excel? I've never seen anybody doing that. And then it becomes more relevant when you look at historical and summary data. So Excel definitely has limitations. So when you look at how many rows you can store in Excel, you quickly run into limitations. So this is one way for you, by using a built-in definition, to assess if a specific framework meets the data warehouse criteria or not. So now let's look at the modern data warehouse architecture by Microsoft. Essentially, when they released the modern data warehouse architecture, there was a big hype about the usage and provisioning of data lakes. And I've done quite a few of these ones. The idea was essentially bring the information from the source systems, put that information into the data lake, and then two things could happen there. The data lake is going to enable our data scientists to start looking for specific patterns and behaviors using the raw information. And then at the same time, we're going to send that information to our data warehouse repository. And we're going to organize the information in there. We're going to create our dimensions and facts and make that information available through Power BI for business intelligence. And this is great. So this works. Essentially, if you go on and provision this architecture, it will work. It will provide business value. There are not any challenges with this architecture. And I would say as well that the technology for this architecture is quite mature. So you could have Azure Data Lake supported by Hadoop file storage in your data lake layer, and you could have actually a SQL Server database or one hosted in the cloud like Azure SQLB, Managed Instance, or Synapse Analytics dedicated pools in here, and then offer those reports to the business. The challenge, on the other hand, by following this architecture, there were two main challenges with this architecture. And they were known even before coming up with this architecture. The first one is that you're still duplicating the information. So that means that you copy all the information into your data lake, and then you copy some of that information into your data warehouse. And so that means that the same information that you have in the data warehouse will be available into a data lake. It's not a big problem, right? Storage is cheap, but you have the information in two places. And that's if the idea is to integrate all the information into a single place, now you have two copies. And the other challenge, I think, is the most important one with this architecture, it was that there was not a huge adoption of the data lake information. And this, I guess, there could be many reasons for this, but one of the key points on why people were not using the data lake is because they were not mature enough. So when you look at, think of the data maturity of your organization, right? Is your business ready to start creating machine learning models? And if for any reason the answer is no, so that means that maybe there was not, you were not enabling 100% the value of your data lake. Yeah, it is a future-proof capability, and that's fine. But to move the needle within the data analytics maturity, it takes time. It takes years actually to move from a, I guess, prescriptive data analytics point of view to a descriptive analytics point of view to a prescriptive analytics point of view. So for your organization to mature, to move the needle, it takes a lot of time. So there were many organizations provisioning this architecture that were not ready to take advantage of the data lake. And essentially this helped come up with a new design pattern, with a new architecture. And that's exactly, that's the reason. So using, because of these two challenges, the data lakehouse architecture was born. As before, try to achieve the same outcome. So we're trying to integrate the information and trying to offer the data warehousing capabilities as we know them, and the advanced data analytics capabilities. So traditional BI, as well as advanced data analytics like machine learning and so on. But in this case, we're starting to optimize resources. We take advantage still of a low-cost storage in open format, and we'll touch on this. But the data lakehouse architecture solves some of the limitations of the modern data warehouse. It brings new limitations that we're going to briefly talk about them, but it's a new design pattern for you to take into account. So if you're going to go down the path of creating a greenfield environment, this is an architecture you have to consider, because there's a huge push from the technology providers like Microsoft and Databricks to use this architecture. And that will mean that some of the limitations that we currently have in the architecture will disappear in the future. Let's look at the different tiers. So when you look at the storage layer, essentially this is supported by bringing one lake into Fabric. So when you think in Fabric, what's the technology that is going to give you the data lake capabilities? That will be one lake. When you think of Synapse, this will be essentially Azure Blob Storage Gen 2 with hierarchical namespaces enabled, aka data lake. Really, cost effective. I would say, look, if there is one thing that is cost effective in cloud, is storage. And the less cost effective things will be essentially compute power and memory. And compute power, call it CPUs / GPUs, memory, and then bandwidth. So moving information. So those are the less cost effective items. Then when you have to enable the metadata layer, so this brings most of the traditional relational databases capabilities. So you have the information sitting in your OneLake, in your data lake, and you're going to apply a metadata layer to that information. So that means that you're going to be able to create and enforce the schema of those assets. You'll be able to create tables, to create columns, to assign data types to those columns. The information is going to be, you'll be able to create indexes, there'll be statistics related to those tables. You'll be able to have versioning of those tables, as well as time travel, partitioning, ACID transaction, and so on. So all these capabilities, you will bring them essentially from our well-known relational database management systems, and we made them available with Data Lake. This is key. So remember this, Data Lake is going to enable us, it's an open source file format that is going to enable us to create delta tables. And the delta tables are the ones who enable you to apply the metadata layer. And as well, they take advantage of the Parquet files fundamentals, highly compressed, highly effective, and you have to make sure you apply best practices when storing the information to take advantage of this, I guess, performance optimization. So we've seen the storage layer, the metadata layer, and then it comes the APIs layer. So this is the set of APIs that are going to enable to access the information. You could think in Fabric, what we have right now to access the information, you have the warehouse with SQL that we're going to quickly see today, and you have the Lakehouse by taking advantage of the notebooks experience with Python, PySQL, and so on, that we're going to briefly touch on that. Databricks has the notebooks experience, Synapse Analytics has the notebook experience, and so on. This is essentially how you access the information in your OneLake. And finally, the experimentation and serving layer is how you make that information available. And you can do that in Fabric through Power BI, creating alerts using Data Activator, or creating machine learning models using data science. None of this will be possible if you don't move the information across the different stages. So if you were going to work with the traditional bronze, silver, gold layer, or move the information from source systems, so you have to bring some tools that are going to allow you to move information. And that's when in Fabric, to move the information and orchestrate that data movement, you use data factory, data engineering capabilities, and real-time analytics. So to summarize, this is how a Lakehouse architecture looks in Fabrics. Does it meet the criteria that we saw before from the definition from Bill Inman? It does. It covers those capabilities. The good thing for us and the bad thing at the same time is that in Fabric, we have many tools to achieve the same outcome. So depending on your skill set or your business needs, you might end up using Data Factory or data engineering to achieve the same outcome. So I would say there's a common question, right? Which one should I use? Should I use the warehouse or the Lakehouse? Should I use factory or data engineering? The reality is that it comes down to the skill set of your team to start with. So I think that's 90%. So 90% of the answer to that question will be based on the skill set of your team. The other 10% will be related to what business problem you're trying to achieve. Because the capabilities that you get in data engineering with the notebooks and the capabilities that you get in factory with the flows, as an example, are slightly different. So some of those tools, they will be better at specific things than the other one, put it that way. The same with the warehouse and Lakehouse. Let me just check if we have any questions in the chat. And any questions so far? You can put in the chat.
If you'd like to ask a question, please feel free to turn on your mic or camera and just shoot it.
Don't be shy. Yeah.
Yeah.
All right. Before we go to the demo, right? Let's talk about limitations. So what are some of the limitations of this architecture? We talked about the good things, the challenges that we're solving, the big push from Databricks and Microsoft for us to use this architecture framework. Some of the limitations that I see in this architecture are related to the life cycle of the architecture. When you look at traditional data warehouses with relational databases, and with this I mean bring the information from the source systems, put in the relational database, and create reports. We were able to mature that architecture frame, that specific design and architecture for 40 years or 50, longer than I've been alive, right? So before I was born, they were already building data warehouses. That's the reality. So there was 40 years of maturity in the architecture. During those 40 or 50 years, it's crazy, right? During those 40 or 50 years, we were able to solve many of the limitations, and we were able to build a really strong community around those specific designs. And there were a lot of technology providers creating tools for us to build those solutions. We were using SQL Server Management Studio. We were using Visual Studio. We have, even within SQL Server Integration Services, when we had to move the information between systems, we have many providers offering different extensions, right? We learned a lot from that architecture framework. With the Data Lakehouse, this is something new. So my point of view is this is something new, and it will take many years to, I guess, catch up with the progress of some of the traditional relational databases. It's going to take many years, and we don't know if it's going to be possible to have many vendors offering us extensions that we can easily plug in to speed up the creation of reports or the creation of data movement solutions. And on the other hand, on top of that, you have to think that the technology is new, and I love Apache Spark and I love Databricks. I'm a big advocate for them, right? But it's relatively new. So when you think of Parquet files and Delta files, it is something new. So we might build an amazing solution around the Delta Lake files that in 2 or 3 years is no longer relevant because we might come up with a new file format. It could happen, a new framework, a new architecture design that is better than the data lakehouse. And those are the things that we have to take into account. So this architecture is something new. When you look at the white papers, the first one written by the people from Databricks maybe goes back to 2021, 2020, the earliest. So that means that this architecture has to mature a lot. Using, you're going to see today, we're going to be using the web browser to perform some work. You know that's not any faster than using a client tool like Visual Studio Code or SQL Server Management Studio. And still those tools, they can connect to the environment, but they have to catch up in regards to capabilities. So those are the limitations that I've seen as a data practitioner. Hopefully, because of the adoption of this architecture, the limitations, they will decrease. So it's just a time. Time will make sure that the list of limitations decreases from a really long list, to a really small list. So let's go on and look at a few things, right? So we're going to look essentially at the different layers. So we're going to look at the one lake layer. We're going to look at the metadata layer, and then use the warehouse Power BI to display some reports and move the information with Factory. So let me switch. Now is the moment that I'll switch the screen. So I bring my development environment. It won't take long. All this over here. And okay. Yeah, that's fine. You won't get much from the AdventureWorks details. All right. Look, let's start with pricing. So all the things that you're going to see today. So essentially, you can start using Fabric. And I'm really happy about sharing this with you, right? So you can see using the Fabric capacity starts at essentially at $300 US per month. So all the things that you're going to see today start at this pricing tag. So this is the entry tier, and then you can decrease that if you get a reservation for 1 year. On top of that, you need Power BI licenses for building Power BI reports. And I won't go a lot into licensing, but this is, from my point of view, is extremely cost effective. I'm really happy about this, where pricing ended up. Then there's always the question, how much can you achieve with 2 capacity units? And the easiest answer is you have to go and test it. In small environments, you might get around just with this tier. As you have more data, you'll have to go up. In Fabric, let me go here. The first thing that we have to do, so this is my Fabric trial workspace. So the first thing that we're going to do is we're going to create a test workspace. So user group, workspace, and make sure that we are using trial for Fabric, and click apply. So it's a blank canvas I want to see. So I'm starting with Fabric, and essentially what I want to do now is to bring some information from an Azure SQL DB into one lake. Before I can do that, to bring that information to one lake, I have to create as well the destination. The destination will be one lake, but I have to have that metadata layer as well. So I'm going to create a warehouse. Come here, create a warehouse, and call it user group. Super original today for the names. And in here, I'm taking advantage. This is like how we're going to use that metadata layer. And one of the big changes when you look at the warehouse experience and you compare with Synapse Analytics is that we're going to be able to start creating objects into our one lake by using this warehouse experience. You could use as well the Lakehouse. There are a few differences between the warehouse and the Lakehouse. For SQL, and the warehouse experience is for those who prefer the notebooks experience, and they come from an Apache Spark environment. So here I am in my warehouse, and what I'm going to do is just create a few objects. I'm going to create a table and insert a row, and we'll see this table being created in the warehouse. So you can see here we're taking advantage of this APIs layer and the metadata layer. So we're creating a table. That table has columns, and I'm inserting a row. If you are working with a warehouse, you can do a few really nice things, like creating a store box. That insert information. So we were unable to do this in Synapse Analytics, as an example. And you'll be able to create as well store procs that update the information, which is quite amazing. So let's look at our new table. And you'll see that now we have a new table with potentially just one row. And we're going to run essentially a store proc to insert an arrow. Let's call this one the word. Execute that. And now we have 2 rows in there. You can do things like updating the information. I'll give it some more time, but let's say that I want to update Enterprise Data Word 2024 to 2026. Run that one. Bear with me, they will come together and how it relates to the warehouse. So what we're doing right now, let me just bring this screen for a sec. So what have we done so far, right? So the first thing is that we have connected to our Fabric experience. We have created a warehouse. We have created a few tables, applying some structure and metadata to those tables, and those tables that are stored in one lake. The next thing that we're going to do, so we're going to show a few more things in this table later, but I want us to essentially go and bring some information. So which is another component. So you have to move information from source systems to your Lakehouse architecture. And we're going to use the data factory experience where I was before. You have the data flow Gen 2 experience, which is absolutely amazing because you can use the same Power Query that you were using the Power BI reports to move the information from source systems into your warehouse or Lakehouse in Fabric. This is one of them. I'm really amazed about having data flow Gen 2 because we're not going to use it for the demo, but let me open it. Just click in there. I'll tell you why I'm so amazed about this one. It's because of the number of connectors that you have here. So when you go and get data, in the previous version, essentially, if you were using Data Factory, you know the number of connectors was around 70 and 90. But here, the idea is to include most of the connectors that you have available in Power BI, potentially will become available here, and then you can just drop that information directly into your warehouse and Lakehouse. For the scenario today, so let's close this bit. So we're going to just use a pipeline and bring some information from an Azure SQL DB. Let's create that one, and I'll show you. We're going to bring 3 tables only. So let's use the copy data assistant. And let's go next. Sorry, let's connect Azure SQL DB. And I have an existing connection. You already have my connection string and password. You are welcome to join the $6 database. And we're going to pick up some sales tables. And here I always work with the customer, order, header, and territory. So those tables that come from the source system, and our destination will be our warehouse in this case. Because that's exactly what we're using, and load that information to new tables. Click next, next, and save and run. And now it will ask for the tables that I have to be loaded, and that's all. So right now, I know maybe I went a little bit fast through that wiki, but the whole idea I want to showcase is that with Fabric, you get speed. And speed means essentially that you as a developer you'll be able to produce more value for the organization faster, and to go through proof of concepts faster, and to test things faster. Using that, only with a few clicks, I was able to connect essentially to extract information from the source system and put that information in the warehouse. You've seen as well when we had an option to create new tables. And those tables, essentially, they're being created in our Lakehouse architecture. So if we go back to SQL, our warehouse, and expand schemas, now we have a sales schema with a few tables in there. And on top of that, we can, let's close this bit, and we'll go to the model option. And we're going to create essentially a model for our new tables. So let's see, a new semantic model. And let's say that I want the tables of the sales schema. Now have reviews. And create a new semantic model ready for reporting by bringing information that we just imported. So this is a lot of speed for, it's going to allow you to start producing essentially visuals faster and to work with the business users faster for answering business questions, right? So let's go and put the relationships. So we know the customer ID goes with customer ID. And that seems to be right. One to many to one. Yeah, so one customer here. I'm really happy. It should be the other way around. Let me see. It should be one to many. Yep, that looks right, and we'll do the same with sales territory ID. So this one here, we will go there. So same here. This should be one to many. No, so now we have our dimensions and our fact table, and we can essentially just hit new report. I don't know why it's asking for the credentials. Okay, this is great, but I want to do something even greater than this. So let's go back to our workspace. So this created a new semantic model. This is a semantic model just with our tables. I want to just click in there and go and hit essentially create auto create report. And this will create basically using the information in the semantic model, come up with a few ideas on the visuals that you can present. This touches on, so you've seen so many components already. I know it's a lot to take in today, but you've seen the warehouse, you've seen the factory moving information. Now we're looking at Power BI, and we're going to go down actually to see the one lake before we start wrapping up. So you can see how fast actually we were able to produce a report. And imagine the future of this with Copilot experience and everything. This will unleash a new level in the data analytics world. So have some information to share, but what's happening behind the scenes? So far, you've seen a table. What's really happening behind the scenes? So in the moment that you bring the information to OneLake, there is actually a client that you can use that is OneLake. So you can, this is like a OneDrive. You can see it in there. I don't know if I can, let me see if I can zoom in, but you can, this is a client tool that you can download to get essentially an idea on the folder structure in the OneLake. And in my OneLake, so you can see here, I want to refresh this OneLake, make this folder bigger. Now you can see that we have a user group workspace folder. That's my workspace, and if I go inside, was it the same workspace? Yep. So if I go inside, you'll see I have my warehouse and you can see the tables structure in here. This is essentially using Delta Lake, the open source file format supported by the community, and this is what it's going to enable you to do things like time travel as such. So if you wanted to go and query a previous version of a specific table in the data engineering experience, I find it easier to do. We're not going to save that report, but we're going to create a notebook and look at how we can look at the time travel of the tables. So this is a different set of tools. As you can see, you can combine different languages in the same notebook, but you can see on the left side, the first thing, I don't have any tables to work with, but we created one in the warehouse. So, and I don't want to go through the same process of copying the information from the source system to the Lakehouse. I just want to connect to the warehouse table. You can create a link. System up. We want to create a new Lakehouse. See, we don't have any Lakehouse. Now when I expand the Lakehouse, I don't have any tables. So I want to, with my Lakehouse architecture, I want to connect to a table that I have in my warehouse, and we have to create a link for doing that. And I want to step out from the notebook for the time being, and I want to go to my Lakehouse. Yep. And in here, we're going to create a new shortcut. And in the shortcut, I'm going to point to my OneLake and connect to my warehouse that we created before. And here I'm going to be able to see the tables for sales. So I'm going to read those ones, and I'm going to read events. So this essentially is not moving the information between your warehouse and the Lakehouse, but if you want to use the Lakehouse capabilities and the notebooks, it is going to allow you to create a shortcut to that information, which is quite amazing. And now we just wait for this to happen, and it makes me wonder. Let's see. So we see the table in there, and now we can see the information on the right. So let's open new notebook. So now our tables are already in there. So I wanted to show you some of those metadata layer capabilities like time travel. So you remember how we inserted a few records in there. So by using, I want to use SQL because I'm good with SQL, but I'm not good with other languages. So I want to describe the history of the versions, the different versions of the events table. While that is running, I'm going to create a new step here. So essentially query a table at a specific point in time once this is ready. So you can see that for that table we have multiple versions, version 1, 2, and 3 from the creation and so on. So I want to just query that table at a specific point in time. So let's say how that table looked at this time, 9:47:58. So let's put 9:47 and here 58. So we want to query a table at a specific point in time, and then you want to tell me the earliest that we have is 9:47. I feel we have too many. So 9:47. That's me playing with a. It's 9:47, and here will be the 8, and now we can remove that bit. Be reviewing my code. Let's say so 9:47:58. It will land just after version 1. You see the version one of that table, there was only one row. And if we go like a few seconds before, let's go 56. So this was the version when the table essentially was empty. So you can see how you start looking at those time travel capabilities. How much are you going to be using time travel for creating data analytics reports? I would say not a lot, but it's good for logs, right? And when you think of slowly changing dimensions, I think it's a good thing to have to be able to compare different versions of tables, but it's definitely not intended for slowly change dimensions, type 2 or anything like that. Okay, this is just version of the table as a whole. Any questions so far in the chat? Let me go on, open the chat.
Hey David, Lawrence
here. Yeah, go ahead. Hey,
pretty impressed. Yeah, good, thanks. How are you doing? Pretty impressive what you can do with Fabric so quickly, like without having to spin up all the Azure instances and then waiting for them and having them to connect to each other and have a data factory, etc. What I'm mostly curious about is, okay, let's say we have in your case, we have a few tables that are quickly to load, but let's say we are talking about larger data volumes, maybe a fact table of 10 million or 20 million rows. Would it be, we have to test, of course, right? So the question is always we have to test, but what about setting up an incremental process of data into Fabric? Would we try to load data incrementally from a SQL server, or would we always do a full copy? What has your experience been with Fabric for incremental refreshes?
Right. So look, taking into account my few months of experience with Fabric, the reality that nobody is going to have a proven answer to that question. Okay. Your approach is the approach that I'm following, but I'm not working with large volumes of information. I managed to do incremental loads. You don't really want to do full loads every time, especially with working with those large tables. I did hit, look, it was faster for me in some scenarios to just go with data factory and the copy statement, the kind of based on the polybase technology. I feel that was faster than using some of the capabilities in Fabric, like the data flows. As well, what you get in data factory experience as today. So let's say data flow Gen 2, I found this to be great. I did hit some performance limitations. That could be my fault, and the tier that I'm using the lowest tier. Maybe if I scale up, it goes faster. What I used to love a lot is the pipelines experience. I used to use the pipeline experience, use the copy statement, move information, to a data lake, from source system to a data lake. That was really fast. The limitation, put it well, right? So this is using one lake supported by the Azure Blob Storage and so on. Writing in the disk, writing in the one lake is never going to be your problem. That's fast. That's really fast. So our limitations are going to be between basically the compute power that we allocate to those activities using the notebooks and data flows, aka Apache Spark running in the backend. So those are going to be our limitations. But I haven't tested. Look, I'll step back. If I go back to your question, right? I haven't tested with large volumes of information.
Yeah. Okay. But that's helpful. Helpful context to then indeed do a proof of concept myself if it comes to it.
Yeah. Look, I think all of us we're going to find that a little bit challenging. I think I closed the. Let me see if I close the pricing bit. Right. So, but the reality is what I told you, this is the starting tier. So if you are working with large volumes of information, you're going to go over this. Now, any of this, especially let's say from F32 going down, that's cheaper than setting up the whole modern data warehouse Azure infrastructure.
Yeah.
And if you manage to fit within any of these tiers, I think you'll be winning. And you're right. Look, my clients, I used to go to my customers, and the building infrastructure and getting them on board of the on Azure and all the things. It takes some time. It is fast, maybe, but it takes 1 week, 2 weeks of effort, right?
Yes.
Especially a greenfield environment.
Yes. And clients love Fabric because, I mean, it's more for the citizens as well, like the business people. They can get a hand of it. It's not like it becomes too technical for the business that they can never touch it. With Fabric, it actually opens the door for the business to be involved as well. The more technical business people, of course.
Yeah. I think that's a good point if you want to stay in the positive side. At the same time, all these tools will mean little to most power users, put it that way.
Mm-hmm.
And another big limitation that thank you for help me remind this one. Another big limitation of this platform is that, you can bring everything in, but it might be difficult for you to move out. And it is fully integrated. You can query the OneLake with Synapse, and you can query the OneLake with Databricks. But when you compare before, if you had infrastructure in a SQL Server database, Azure SQL DB, or dedicated SQL pools, taking out the schema from there and putting that schema in another technology provider was a known method.
Yes.
We knew we could migrate things. Now with the software as a service offering like Fabric, once that you move everything in, it's not really clear or mature how to get out. Let's say if your company wants to move to a different provider, that path right now is inexistent, put it that way.
Yes. Yeah.
Okay, let's start wrapping up. I've covered a lot of ground. You've seen a lot of speed. We've seen as well. I wanted to show you how it looks with Databricks as well. So if you want to build the Lakehouse architecture with Databricks, the component in Azure, the components are quite similar. If you want to do it with Synapse, let me see if I have the Synapse. Nope, I've removed the Synapse one, but it's quite similar as well. So in only a few moments, we were able to have a brief look at all the different components, a lot of speed. With the speed comes problems sometimes. You get a speed ticket, and that's not good sometimes because you're going too fast. Might not be good for the organization. And the other one, look, I'll leave you with a few resources. The third one, look, this is one of the first papers. No, the last one actually is one of the first papers about the Lakehouse architecture. I'll put these links in the chat. If you wanted to, let's summarize this to do it the proper way, right? Lakehouse architecture is just one more architecture framework for you to take advantage of. It's a new design. It's a lot of push from the providers for us to use those frameworks. It doesn't mean that is what your company needs. If you were going to set up a greenfield environment, you should look at using the Lakehouse architecture and Fabric as part of the assessment. If you already have a functional data warehouse, I will not migrate that to Fabric unless there are major ongoing cost benefits. And if your data warehouse is not functional, again, I guess you could look at Fabric and the Lakehouse architecture to solve to create a functional data warehouse. Really easy to get started, low cost storage and entry tier for Fabric, a few limitations and unknowns in regards to the adoption and how fast it's going to mature. But look, I think that's all for today. Thank you for joining this presentation. If you want to connect with me, just go and reach out in LinkedIn. I'll put those links in the chat, and yeah, thank you for organizing.
Thank you so much. That was a great session.